this by email. Some of you I'm expecting to kind of just follow along and do it as we do it. Okay.
Functions?
So you have a function from that. Did you see this one?
Hey, what's my answer to this?
Naturals to naturals, yeah. And it has this funny property that for any for any
Where's my answers?
Is it not that one? No.
No.
for any n.
There's one with the swastikas on the back.
Just sit down.
Yeah, just keep following. Do you want another piece of paper? Is that what you
No, I've written my answers
You
off.
can rewrite it.
Oh, did you write it on the swastika page?
Oh,
I
yeah.
might have put it on the page. I was trying to get rid of the evidence.
No, that's the wrong swastika. There's too many swastikas in here.
Okay, so if for any n, if D1, D2,
Oh, there it
D3,
is. Yeah, found it.
D4. I guess the question is like, I should tell you where the question is from as well. Hold on.
Angry swastika.
Okay. So
I can't
there's
copy his 3D swastika.
these are the list of positive divisors of n, right?
Yeah.
Okay. If that's a list of positive divisors of n, then the function has to satisfy f of d1 times f of d2 times like all these together f of dr, yeah?
Like
Is equal to
dr equals.
I've got two solutions. One is
it
like big brain.
Is it like in
Oh, we didn't order them. Well, you can probably order. I mean, you can order them however you want.
Michael?
Yeah.
I've got two solutions to this. One is big brain and one is small brain. So I don't know. But you said there's only
Is
one
there a
that
function
works.
called small brain?
Yeah.
It's a
Yes.
natural to naturals. Small
No.
brain. The other function's good.
Fn equals small brain.
No, so like if dr is the biggest one, right? So that's equal to n, right? Because the largest factor is itself. The largest factor of a number
Okay,
is
you can
itself, right?
if you order them increasingly. Okay.
Yeah. And so, if it's not equal to n, if dr is not equal to n, then it becomes 1. F of that is equal to 1. And if dr is equal to n, then it is equal to n. So there's 1 times 1 times 1 times 1 times n, and that's equal to n.
I found my one.
That's a really dodgy one.
I'm so confused.
It's very simplistic.
Well, with D1 and D2 can't be equal. This is
Do they have to be separate?
It should be
Well,
on top.
yeah.
It should be on top.
Did you find another one with like swastika as well?
Yeah. Maybe.
It's like a
It
3D
could
one.
also be on the top up there.
Oh yeah, 3D swastikas up there. You made it. And I tried to copy it, but I failed.
Yeah. So yeah, next time if you leave your working, make sure you leave it the Schwarzschild side down.
Good job, Kyle.
Usually there wouldn't be
It
these
looks pretty
problems.
nice.
Like, can you imagine these problems? Like, it's like, how do you tell people about this? It's like, you can't even, like,
Oh yeah, some of the pieces of paper.
it's like I get counselling and my counsellor will be like, what are you talking about? Like, I can't even
But-
explain
What
this.
do you get counseling about?
You and like other people in the class and
Really?
stuff. No.
Yeah. No, he said if he got.
If I got it, wouldn't be
So
worth it. That's what I'm
elegant.
saying.
Hey, I drew this in 3 seconds. So
No, that
Okay,
looks
so
bad.
this is the problem. You have to find all the functions that satisfy this property. Yeah?
One is big brain, one is small brain. Which one should I do?
No, we didn't ask.
The small brain's pretty small. But
Okay, so basically, I think it's really good to
This guy
start with
said-
like small numbers. Yeah. Look at small numbers. Like n equals 1. Yeah. Okay.
Then F of
What are the factors of 1?
1.
1. Okay. So what do you get? You get f of 1 equals 1, right?
Whoa.
So that's like the easiest f of 1 equals 1 we've done. Okay.
F of X is
F of 0 is equal to 0. Oh, but that's not
It's,
natural.
We didn't have 0
It's not
because
natural.
that list wouldn't be defined as 0. So like I think we're assuming that naturals.
Positive.
we're-
Wait, doesn't it
we're-
say positive natural?
We're deleting 0 from the set.
I think it
was-
says positive natural.
Yeah.
Come on.
Okay, what happens if n equals 2, yeah?
1 and 2.
Then f of 1 times f of 2 equals 2, right? Yes, so can you see that f of 2 has to equal 2, yeah?
And F of 3 has to equal 3.
Yeah, okay, what's the factor f of 1 times f of 3?
That's how you figure out the if statement for prime numbers.
Okay.
Yeah, so can you see it's clear that any prime
If
number is only 1 in p,
I
right?
called it an if
So
statement.
then f of p has to be
Equal to p.
p, yeah?
Yes.
For prime.
That's my if statement.
Yes.
Yeah.
I
Okay.
think like my rule screws up because
But then all the other ones have to equal 1.
when it's 1,
Yeah.
2, and 4, right?
Oh, so then if it's not prime.
Right, but like
That doesn't
powers
work.
of prime is equal to prime as well.
Yeah. Yeah. So,
Oh, fine.
so if you have like a power of a prime, right? So like let's just do p squared, yeah? You have like 1, p, and p squared, they're the factors, yeah?
Yeah.
So then you have f of 1, which is 1.
Yeah.
Okay. P is p, right?
Oh, yeah.
And then you times this by f of p squared equals p squared, right? So then f of p squared
Is
has
it gonna
to be
be?
p, right?
Yeah.
Wait, that satisfies my square condition.
I mean,
Square if statement.
What is D1, D2?
I'm not sure if my big brain thing
They're all
works
the
here.
divisors.
so these are all the divisors.
I don't know. Wait, Kyle, does it also
Or
work?
N?
Yeah, the divisors of n.
Do you remember what my solution was?
It was like square root.
Yeah. It's square root of the number of factors. It's pretty cool though.
All the divisors of n, yeah?
It's like
So see if you have p squared, yeah?
Yeah.
What are the divisors of p squared? It's
It's
Depends.
1. So you have
P.
f of 1.
Is
You
that
have
how it
p.
goes?
You have f of p, right?
chunky gummy bears.
Okay, that's the name.
There's
Chunky
only
gummy.
3 flavors.
Yeah, what's
And
it
then you have
called?
f of p squared, yeah? And that times together equals p squared. That's the condition. And so we know that this is equal to 1 and p, right? So then f of p squared has to be equal to p as well. Okay? And if you kind of do this, you can kind of see a pattern, right? If you have p to the power of 5, say, or p to the power of 3, yeah?
I took the only green one.
You have like
Good job, Koban.
f of 1,
That's
f
the
of p squared, f of p cubed, right? Okay, but then we know that all of them are equal to p up to f of p cubed, yeah? So we know 1 times p equals p cubed, right?
Yeah.
So that forces f of p cubed to be p as well. So if you continue, I guess, yeah, if you continue, you have f of any prime power, right, is equal to p. Okay?
That screws my solution up, I think.
Dude, how does your square root solution work? Like, I don't even get it.
Wait, what?
How does your square root solution work?
Yeah, why would
It's not just square root. It's S root.
Why?
Like, how did you even find that solution?
S root N.
Oh, yeah, that might.
S
If you
through N.
divide into each of the.
Yeah, that's what I did. S through N.
But why would you do that though? That's such a
It works.
overcomplicate.
You just randomly find it.
No, I was timesing the things together, right?
Yeah, because you
And I
make
decided to
multiple
like divide it by this, because it becomes
Wait, so they F of
S
P to
times-
power R equals
S
D
divided by
and
2
R
times
equals
the number of things,
What?
right?
D. Is that the
S divided by 2
No,
powers,
this is
right?
not enough
So
to
I
define a
divided by
function, so it's not a solution, yeah?
Root
Oh yeah,
S.
it's only for prime numbers.
So we only know what happens for
And
numbers that are prime powers, yeah, so far. What happens if there's 2 primes times together, yeah? So what happens like f of 6? What if it's like 6, right?
One all others need to be one because you already have all the.
Can we just reduce
Yeah.
them down like all numbers?
So f of
prime
1
factors?
I
times
feel
f
like
of
this is
2
going to disprove my
times
theory.
f of 3 times f of
Probably
6,
multiple
yeah?
solutions.
No, like
Okay.
this just disproves my theory.
Like if 1, 2, 3, and 6 are the factors of 6, yeah?
No,
And
like
we know
my
that all of
solution.
this is already 6,
I
yeah?
feel like this disproves my
So that
solution.
forces f of 6 to be 1, yeah?
But f of 2 is 1. I mean 2. Oh
yeah,
yeah.
so f
Yeah,
of 2 is 2, that's 3,
combined.
that's 1, right? So that's 6. The 6 cancels with the 6.
Got
So
it.
f of 6 is 1, yeah? That
Oh
makes sense?
god,
Yeah.
this is like killing me.
Yeah, so
This is destroying my solution.
actually, can you see a
'Cause this is
potential
what I found, right?
solution is
You do 2 times 3 times
it
6.
takes all the prime powers just to p, right? The prime. And it takes all the non-prime powers to 1.
Yeah.
Like that would be a solution. Yeah? See how that works?
Yeah. It's very easy.
Because the point is, if you have a prime power as a factor, you also have all the ones, like if you have prime to the 6, right? You also have p to the 5, p to the 4, p to the
Yeah,
3.
and then-
So each one of those gives you a p. So that takes care of the p to the 6 of n, right? So that's...
This is how I found my answer. 2 times 3 times 6, right? 36. I want to get back to 6, right? So it's divided by 6.
You divided everything by.
So actually, this is an important part of the number theory that we have to
4
cover.
6.
I don't know if you see this is weird because you meant to kind of cover it in like year
You
8
get
or
6 at the bottom, so
towards
Four-
the end of year
4
9.
through to 6,
at
and 4
least.
through to 6, and 4 through to 6,
Um,
and 4 through to 6.
So
Let's
it's,
think of 6.
if you haven't, you have to make a note of it. And we have to catch it up, okay? So the fundamental
S
theorem of
of
arithmetic,
n.
yeah. So every number is a product of prime
But it
powers.
works. Or it should work.
You can uniquely factorize every number in some prime primes, okay? And the theorem itself, I mean, you might wonder if it's worth justifying because you probably think it's obvious.
Right?
But the things that we need to actually prove it are worth learning in themselves. They're kind of helpful. But I'm going to assume it here, okay? But if you don't know it, we have to catch it up, okay? So every number can be prime factorized. Like this, yeah?
Equally prime.
This is making me feel worse about my solution now.
It's okay.
Okay.
It's okay to be wrong.
And then here you can assume all the primes are different.
'Cause
And
this
the
is
point
one
is,
time
if
I
there
did
was any
homework.
other way to factorize it, you would
This is
also,
the
you
one
would,
time I did homework in this
Oh,
You would-
did it wrong.
Yeah,
so
that's
if you could
that's
factorize
the-
it in another way, it would just be a reordering of the primes, yeah?
Let's duck.
That's what the theorem is saying. There's no other ways to. Oh, listen up. There's no other ways to factorize this in terms of primes. Okay, and if you have this factorization, okay, can you see that f of some of the factors here are like the factors of this is like 1 p1 squared all the way up to p1 to the r1, right? That's all the factors of this, and it's the factors of n as well. Yeah. So if you do f of these, they all get you p1, right? Yeah. If you take f, they all get you p1. So these are primes. Okay. And if you times them all together, then you get p to the r, right?
Wait, why was the green one of them? The other two ducks.
Okay. So p1 to the r1, yeah? Okay. So that means if you take f of just these factors times the f of these factors times it, then you already get n, right? Because of these factors you get p to the r1, p1 to the r1. If you do it for all the other different p's, you get all the other p powers, right? So when you times them together, you already get n, yeah? That means all the other factors that involve other primes must be 1. Yeah? Okay. Okay, so that shows that the only possible solution is the one where primes powers go to the prime and everything else go to 1. Yeah? Okay. And to see that that is a solution, right? Yeah? I think you actually need to assume the unique factorization, right? Otherwise it's not really well defined. Okay? So, yeah. So, I've recorded some lessons on the uniqueness of prime factorization. We need to solve a particular kind of equation. Okay.
Yeah, Michael.
Yeah.
Should I say my okay?
No, your solution. Wait, does it involve fractions, right?
Yeah.
Yeah, then some of them might be natural numbers. It's naturals to naturals.
Yeah. Why is it not natural?
What, natural is only 1, 2, 3, 4, 5, 6.
Yeah.
Yeah, so if you have
So if you have
some
functions of
them might
anything
be-
like 0.5, then it doesn't.
But it's natural to natural. So function, it can't be function of 0.5.
Exactly.
It can only function of 1.
Yeah. So
Yeah.
You can't.
Why not?
Wait, what isn't your like f of d1 equal to a fraction?
Just present your solution.